Hello everybody, this is lesson 2 of the lecture Macroeconomics. I will discuss slide 33 to 60 of the first chapter, Introduction to Macroeconomics. So far we have discussed the definition of GDP. Now we will see that there exist three different ways how GDP can be computed. GDP is defined, as we have seen, according to the way it is produced. This is what we will call in the following the production account. However, following the circular flow model, there are three ways how GDP can be calculated. The first account is, as already mentioned, the production account. This deals with how the cake GDP is made. It shows how large the contribution of various industries to total GDP is. The second account now is called the distribution account. Distribution account shows how GDP is distributed, especially among the various household groups. There are working class households which receive primarily wages and salaries, and there are capital owning households which receive additionally or primarily capital income, like dividend payments, interest and the like. And then, as we will see, there's of course also the government, which receives also a quite important part of total GDP in terms of taxes. The third way to calculate GDP is the expenditure account. The expenditure account shows how GDP is spent. For example, for consumption purposes, for investment purposes, or by the government. So the various ways how to calculate GDP provide us different information. They answer different questions. The production account answers the question, what is the contribution of a certain industry to GDP? The distribution account answers the question, what kind of economic units receive how much of GDP? And the expenditure account answers the question, for what kind of purposes is GDP used? If you take a look at our basic circular flow model, we easily can discover why GDP can be calculated in three different ways. The circular flow model describes a closed circular flow. As a result, it should make no difference on what position of this circle we measure the flow through. If we calculate the production account, we measure the through where it is produced, the making of the cake. If we calculate the distribution account, we measure how the cake is distributed among the various household groups. And if we calculate the expenditure account, we look how the cake is consumed. In the following, I will work out the various components of these three accounts and take a closer look at their quantitative size for Germany. We start again with the production account. The production account simply adds up the value added by all economic units. Most important component of the production account is value added of private firms, which is calculated, as we have already seen, by the sales of these firms minus their purchases of intermediate goods. Another component of the production account is value added of the government A third component is value added of non-profit organizations. As we have already seen, value added of the government and non-profit organizations is calculated as their payroll costs. Another component of the production account that should be mentioned is the value added by private households. As we have already seen, here we are only able to measure the value added by employees that hold in regular working relationship. Okay, this is the definition of the production account, and in the following I will now display the relative composition of German GDP according to this account. For simplicity, the value added by households and non-profit organization is added to the value added by the government. Quantitatively, value added of non-profit organizations and households is not very large. So this diagram shows the composition of German GDP according to the production account, starting with the year 1970 to the year 2018. What we observe here is that there has been some change in the composition of GDP according to the production account. Let's start with agriculture and forestry. The share of agriculture and forestry at the beginning of the 70s was about 4% of GDP. Now it has nearly disappeared. It is very, very small. It's a little bit more than 1%. Another sector with a shrinking share in total GDP is the industry sector. Here we talk about classical industries like manufacturing, heavy industries, and the construction sector. At the beginning of the 70s, total share of this industry sector in GDP was 48%. In the year 2018, the share has shrunk to a value of 30%. This reduction in the share of industry and agriculture and forestry has been compensated by the increase of the share of the so-called service sector. The service sector consists of trade, hotel and catering industries, banking, insurance, real estate and business services, and other private service industries. We see that at the beginning of the 70s, the share of this service sector plus government services was close to 48%. Currently, the total share of these service sector industries is 69%. So this means we have reached an economy today that mostly consists of service sector production. Classical industries are no longer that important for the economy. I think that's a quite interesting information we can receive from the production account of GDP. So let's see what kind of information the distribution account provides. The distribution account shows how GDP is distributed between workers, capital owners, and the government. The most important component of GDP according to the distribution account is net compensation of domestic and foreign employees working within the country. Within the country is an important attribute because it makes clear that we calculate here only wages and salaries created within the country. So we do not count for the wages or salaries a German employee who works, let's say, in France receive from France. We only take care about compensation workers of all countries receive from their work within Germany. That is due to the fact that GDP measures only the value added created within Germany. The second largest component of GDP by distribution account is net income from domestic wealth held by natives and foreigners. Again, here we use the attribute natives and foreigners to make clear that does not count who receives these payments. Important is that they are created from production within Germany. The next component is the share of GDP the government receives. The government receives from companies, private companies, mostly indirect taxes, especially largest part of this is the value added tax, and then a couple of industries receive subsidies from the government. So we have to subtract the subsidies, of course, to get the net value of these taxes that private companies pay to the government. In a similar way, we have to proceed with the taxes the government receives primarily from private households. Private households basically pay income tax to the government. This is called direct taxes. And then again, there are a couple of households which receive transfers, social transfers mostly, from the government. And we have to subtract therefore these social transfers in order to receive the net tax burden households pay to the government. If you add up both components, we would receive the net tax burden private agents pay to the government. The last component of the distribution account is depreciation. This is not the kind of depreciation you know perhaps from tax laws. This is macroeconomic depreciation. As already mentioned, according to the definition of statistical offices, this type of depreciations corresponds to the withdrawals for reinvestment made necessary by the erosion of the capital stock, machines, production facilities, production buildings, and the like. So this is physical depreciation, not tax law depreciation. Since this type of depreciation has to be withdrawn by firms in order to have the financial means to finance these necessary reinvestments, it cannot be paid neither to the government, nor to the capital owners, nor to the workers of companies. Therefore, it is a special component of the distribution account. Now let's have a look at the empirical composition of German GDP according to the distribution account. Here we find again the various shares starting with the year 1970 up to the year 2018. So as mentioned, the largest share according to the distribution account is held by gross compensation of domestic and foreign employees, the worker income in other words. I think it's relatively stable. We can observe a reduction of this share starting at the beginning of the year 1980. The lowest point was reached in the year 2007, 2008. Since then it is again slightly growing. So I would say there is no clear trend in this component. The same holds basically for the gross income from wealth. The only component that shows a trend is depreciation. But that is not very astonishing, as we will see in chapter 2 when we discuss the neoclassical growth model. It is just a consequence of the fact that the capital stock, the number of machines and production facilities and production buildings, is growing in a growing economy, such that there's also more depreciation for this larger capital stock. So this is nothing we should worry about. Unfortunately, we do not have information about net income from wealth and net income from compensation of workers for Germany. Therefore, I can here not display the component direct taxes minus social transfers. So I can only display the component indirect taxes minus subsidies that is paid to the government from private companies. Okay, so the next account we have a closer look is the expenditure account, the way how the cake is consumed. Here we calculate GDP according to the following components. The largest component is here consumption of households. We follow the usual textbook convention and use in the following chapters capital letter C as a shortcut for consumption of households. The next shortcut is government consumption, the part of GDP that is used by the government. The shortcut here is capital letter G. Then we have again depreciation, because this is used by private companies for reinvestment purposes, so it must appear here as a component of the expenditure account. The shortcut for depreciation is capital letter K for the capital stock times lambda. Lambda represents the depreciation ratio, so the percentage share of the capital stock that is eroded every year in the process of production. For Germany, lambda has a value of roughly a little bit more than 2%. Next component is net investment. So net investment is additional investment that makes the capital stock larger, if net investment is larger than zero, of course. Together, depreciation and net investment is total investment or gross investment. For gross investment we use the capital letter I, for net investment we use capital letter N and capital letter I. The next component is exports. Part of German production is not consumed by households or the government or used for investment purposes, but flows to economic agents in other countries. This is what we call exports. The shortcut for exports is capital letter X. Since a part of consumption of households, government consumption or gross investment is undertaken with goods which are imported from foreign countries, we have to subtract the imports, of course. So this is again because GDP measures only domestic production. We receive then a component exports minus imports that is quite often called net exports. That is the expression we will use in the following also. Okay, now let's have a look how the German GDP is composed quantitatively according to the expenditure account. The largest shares of the expenditure account, private consumption and government consumption, are relatively stable. Most dynamics are observable with regard to investment shares and net exports. The beginning of the diagram in the year 1970, nearly 17% of GDP was net investment. Net investment means new investment, new additional machines, production facilities are added to the capital stock. This share has, however, been shrinking to a current level of 3.6%. So tremendous decrease of net investment. As we will see in chapter 2, this is of some importance because net investment is an important source for economic growth. So the fact that currently GDP growth rates are significantly lower as in the 70s can be explained by the fact that net investment has become much smaller. Another feature that becomes observable here is the fact that periods where investment is shrinking are typically periods where net exports are growing. This was observable here in the 80s before the German unification, and it is observable here starting with the noughties. So there have been periods where domestic investment was shrinking while at the same time net exports had been growing. Simple explanation for this coincidence is that in the 80s German companies started to invest more in foreign countries, especially in East Asian countries, because wages were lower there than in Germany. So German companies started to build up production facilities in East Asian countries. While beginning with the noughties, a lot of German companies started to build up production facilities in Eastern European countries. As a result, exports were growing in these time periods while domestic investment had been shrinking. So I think it's clear that the expenditure account of GDP provides us also quite interesting insights in the long run economic development of our economy. Okay, we will come back to these problems, especially in chapter 2 when we discuss economic growth theory. Now this table gives you an overview about the three accounts of GDP that we have discussed now. First, the production account, where basically gross value added of firms or other economic agents is added together. Second account is distribution account. Most important component of the distribution account is net compensation of employees, so basically wages and salaries to working class households, paid to working class households. Second most important component here is net income from wealth, paid to households that own wealth, that have made capital investments in the past. Third largest component, net taxes. Net taxes are a burden to private agents but are the income of the government. And finally, depreciation, the share of GDP that cannot be paid to households or the government because it is needed within the firms to make reinvestment. Third column in this table is the expenditure account. Largest share here, consumption of households, government consumption. Then we have net exports and gross investment, which consists of net investment plus depreciation. So depreciation appears here in the distribution account as well as in the expenditure account. Another component that appears in the distribution account as well as in the expenditure account are net taxes paid to the government. The government uses this tax income to finance government consumption, and if tax income is not large enough to finance total government consumption, the government has to run into debt. That's what I've assumed here. Therefore, this area here symbolizes new indebtedness by the government necessary to finance government consumption. Typically, this is the case. Most governments typically have to run into debt in order to finance total government consumption because most of the years tax income is not large enough to finance total government consumption. Okay, so these are the components you should try to keep in mind. We will need them in the following chapters, and especially the components of the expenditure account are quite important, as you will see. In the next section, we will discuss how statistical offices exclude the impact of inflation on the measurement of GDP by calculating real GDP instead of nominal GDP. Let's start with the problem. According to the definition of GDP, we measure the market value for all goods and services produced within a country in a given period of time. Market value means, however, that the quantities of goods and services are multiplied with their market prices before they are added up. You remember, we used this trick to solve the apples and oranges problem. Now, however, this can result in a new problem. If the prices of all goods and services grew within a rate of nearly 2% per year, which corresponds to the target rate of the European Central Bank, as we will see in chapter 6, GDP would grow by 2%, even if the actual production, the real production of goods and services, were constant. In order to eliminate this effect of inflation on the measurement of GDP, statistical offices calculate real GDP. How is this done? I will first explain it verbally, and then we will have a look at a simple numerical example. So how is real GDP determined by statistical offices? It's a quite simple trick, in fact. Instead of evaluating apples and oranges with their current prices, which results in nominal GDP, they are evaluated with their prices in a fixed year, arbitrarily fixed year. This year is called the base year. For example, real GDP of the year 2008 at prices of the year 1995 informs about the level of GDP in the year 2008 if prices since 1995 had stayed constant. As a result, the yearly increase in all prices, which has taken place from 1995 to the year 2008, the rate of inflation in other words, is eliminated from real GDP. If you keep the prices constant, inflation can have no impact on the measurement of GDP. Now, I think the following example, numerical example, helps to understand this procedure a little bit better. Here I have constructed an extremely simplified economy. We have 3 years, the year 2000, the year 2001 and the year 2002, and we produce only apples and oranges in this economy. This column tells us the quantities of the production of apples. This column tells us the quantities of the production of oranges in every year. This is the price column for apples and this is the price column for oranges. And in the last two columns we measure nominal GDP and real GDP according to the approach just explained verbally. The most important simplification I have assumed in this table is the assumption that apples as well as oranges are produced without intermediate products. So, as a result, the sales of the apples industry and the sales of the oranges industry is identical with the value added of these industries. That helps us to calculate nominal and real GDP without taking into consideration intermediate production. The result does not change, but it makes the example a little bit simpler. So let's start now with this assumption and have a look how nominal GDP can be calculated then. So let's have a look at the year 2000. Here nominal GDP is equal to 2,500 euro. How do we come to this number? Well, first we take the quantities in the apples industry, 100 kilogram, multiply this quantity with the price per kilogram, 10 euro. The result is 1,000 euro production value, value added in the apples industry. Then we take a look at the oranges industry. Here we have a production of 50 kilogram. We have a price of 30 euro per kilogram. So the production value, the value added in the oranges industry is 50 times 30, 1,500. 1,500 value added from the oranges industry plus 1,000 value added of the apples industry results in the number 2,500 euro nominal GDP. The same procedure is now applied for the years 2001 and the years 2002, and we have as a result this time series for nominal GDP. 2,500 in the year 2000, 7,000 for the year 2001, and 16,500 for the year 2002. Okay, that's the normal procedure. Now let's have a look how we calculate real GDP. I measure here real GDP at prices of the year 2001. So this intermediate year, here we take the prices, 20 euro for kilogram apples, 40 euro for kilogram oranges. And we evaluate the quantities of all other years with these prices of the year 2001. Let's see how this works. Let's start with the year 2000. Here we take the production quantity 100 kilogram, multiply this production quantity with the price of apples in the base year 2001, 20 euro. So the result is then a value added in the apples industry of 2000 euro. Now do the same for the oranges industry. We take a look at the production quantity, 50 kilogram oranges, and then we multiply this production quantity with the price of oranges in the year 2001, namely 40 euro per kilogram. This results also in a value of 2000 euro. 2000 euro value added in the apples industry plus 2000 euro value added in the oranges industry results in a real GDP number for the year 2000 of 4000 euro. And now we apply the same procedure for the year 2001. Of course, since we use the prices of the year 2001 for all years, we have to do the same with the year 2001, and then it is clear that nominal GDP and real GDP in the base year is always identical because we use the same prices for the calculation of both numbers. So we have a nominal GDP value for the year 2001 of 7,000 euro, and we have a real GDP value for the year 2001 of 7,000 euro. There's no difference. If we apply the procedure, however, to the year 2002, we will of course receive different numbers for nominal and real GDP. So let's do this. Production quantity of apples in the year 2002 was 300 kilogram times the prices of kilogram apples in the year 2001, 20 euro per kilogram, gives a gross value added of apples production for the year 2002 of 6,000 euro. Now, production of oranges was 150 kilogram times the price of oranges in the year 2001, 40 euro per kilogram, results in a value of gross value added also equal to 6,000 euro. So 6,000 euro plus 6,000 euro gives a number for real GDP equal to 12,000 euro. Okay, that is the way how we calculate real GDP according to the procedure just explained. Now, before we interpret this result, let me give you an overview how nominal and real GDP have developed in Germany over a longer span of time, starting with the year 1970 again. The jump both time series make in the year 1991 is due to the German unification. After 1990, East German and West German GDP are added up. Okay, now let's have a look here what the base year was. According to the formula, the base year is the year where nominal GDP is perfectly equal to real GDP. Well, unfortunately, we have here a couple of years where this could have been the place, so I have to tell you that the base year was in fact the year 2000. Before the base year, the green line, real GDP, is always a little bit larger than the red line. This is due to the fact that in calculating real GDP we use the prices of the base year 2000, and since there has always been inflation in the years before the year 2000, real GDP is always larger than nominal GDP. After the base year this changes. After the base year we experienced inflation again, and therefore nominal GDP is now larger than real GDP. However, the comparison of the level of nominal and real GDP is perhaps not very informative. It's much more interesting to look at the differences in the growth rate of real GDP and nominal GDP. The elimination of inflation implies that in times of positive inflation, the growth rate of nominal GDP is always larger than the growth rate of real GDP. This follows directly from our simple numerical example. We can now use the time series we have calculated for nominal GDP and the time series of GDP we have calculated for real GDP to calculate nominal and real GDP growth rates. Growth rate of a time series is always the percentage change of this time series from one year to the other. So this implies that we take the value of 1 year before, calculate the absolute change and divide this absolute change to the value of the time series 1 year before. If you apply this formula, we cannot calculate the growth rate for the year 2000 because we do not know the level of nominal and real GDP of the year 1999. So we can only start calculating GDP growth rates with the year 2001. Okay, that's what I've done here in these two columns. Let's have a look how we apply this growth rate formula. So we take the value of nominal GDP in the year 2001, which is 7,000 euro, minus the value of nominal GDP 1 year before, 2,500 euro. Then we divide this absolute difference by the value of GDP 1 year before 2001. So this value, 2,500 in other words. This results here in an extremely large 1 year growth rate, 180%. This is due to the fact that we had strong increase of production quantities from the year 2000 to the year 2001 and a strong increase of prices. This results in this very huge growth rate. For the year 2002 we apply the same formula and then we have as a result a value of 136% growth rate. Again, extremely large growth rate for the same reasons. Now, the same formula applied to real GDP results in the following growth numbers. We have to take the absolute value of GDP in the year 2001, real GDP in the year 2001, 7,000 euro, minus the value of real GDP in the year 2000, 4,000 euro. This absolute difference is then divided over the value of real GDP in the year 2000, 4,000 euro. And this results now in a somewhat smaller growth rate, namely in 75%. So, real growth rate is now smaller than the nominal growth rate. Why is this the case? Or how can we interpret the difference between nominal and real GDP growth in the year 2001. Well, if you take a look how we have calculated nominal GDP and real GDP, then it should be clear that nominal GDP contains the impact of real GDP growth plus the impact of price inflation, while real GDP contains only the impact of real production growth. So the difference between both growth rates is basically inflation. A very rough measure for inflation would be the difference between nominal GDP growth and real GDP growth. As we will see, however, it's an inaccurate measure since it results in an approximation error, which is the larger the growth rates are. In the following, we will therefore develop a procedure to calculate the true inflation rate without this approximation error. Nevertheless, this interpretation makes clear that the difference between nominal GDP growth and real GDP growth is caused by inflation. Now let's have a look how we can calculate the true inflation rate, the accurate inflation rate. Here we can use an interesting side effect of the calculation of real GDP that we have undertaken so far. This calculation delivers us an indicator that we can use to measure the rate of inflation. To do so, we first take the value of nominal GDP of each year and divide this value by the value of each year's real GDP. The resulting time series is called GDP deflator. It's a measure for the average price level in this economy. Therefore, the growth rate of this GDP deflator corresponds to the rate of inflation of all the prices of all goods and services in this economy. Let me show you why this makes sense. Let's start with the definition of the GDP deflator according to the formula just mentioned. So we take for every year nominal GDP and divide nominal GDP over real GDP. The number we receive then is what we call GDP deflator, the measure of the average price level in this economy. To see why this makes sense, let me give you the following memory hook. Let's assume we would produce only one good in an economy. Then the nominal GDP would be the production quantity of this good, Y, times the price of this good, P. Real GDP would simply be the production quantity of this one single good. Now, if we divide nominal GDP over real GDP according to this formula, we would have production quantity times price over the production quantity. And as a result, production quantity cancel each other such that the result is actually the price level of this good. So I think this memory hook shows in an intuitive way why the GDP deflator calculated according to this formula contains information about the price level in an economy. Let's apply this formula now to our numerical example. Here again we have the table with the time series for nominal GDP and real GDP. In this column we measure the GDP deflator. So we take the value of nominal GDP in the year 2000 and divide this value over the value of real GDP in the year 2000. The result is an index number with the value expressed in percentage terms of 62.5%. if we apply the formula for the base year, where nominal GDP and real GDP are identical, we receive, of course, on a percentage base, a value of 100%, since nominal and real GDP are identical in the base year. In the following year, in the year 2002, we again have to divide the value of nominal GDP over the value of real GDP, and the index number here is then 137.5%. Now this is our GDP deflator, a measure for the price level in this economy. The inflation rate, that's an important point, is not the price level. The inflation rate is the change of the price level. So what we have to do to calculate now the inflation rate is we have to take the formula for percentage change and apply it to the GDP deflator time series. So let's do this for the year 2001. We have to take the value of the GDP deflator in the year 2001, which is equal to 100%. So we have to take 100% minus the value of the GDP deflator in the year before, 62.5%. And then we have to divide this absolute difference over the value of the GDP deflator in the year 2000, 62.5. Then the result is a growth rate of 60%. So this is the inflation rate from the year 2000 to the year 2001. The percentage change of the price deflator. According to the same formula, the inflation rate from the year 2001 to the year 2002 is 37.5%. And that is now the 100% accurate inflation rate for this economy. So this is our simplified example. Now let's have a look at the GDP deflator for Germany over quite a long span of time. Here we start with the year 1960. And, well, it's again not very informative to look at the level. Nevertheless, what we can see is that the increase of the GDP deflator over the first 40 years had been quite strong, so the slope is quite steep. After the year 1999, the slope gets much flatter. This change in the slope is most likely caused by the transition to the European Monetary Union, which started in the year 1999. Okay, one question left here is, what is the base year of this GDP deflator? Well, according to our calculation, we know in the base year nominal and real GDP are identical, so the GDP deflator should have a value of 100%, and that was the case exactly here in the year 2005. Now, as mentioned, look at the development of the level of the GDP deflator is not very informative. It's more informative to calculate the inflation rates based on this GDP deflator. To do this, we have to take the value of a specific year, calculate the difference between this value and the value of the GDP deflator 1 year before, and then divide this over the level of the GDP deflator of the year before. That's what I've done here for every single year, and I have presented the result in terms of these red columns. And we measure now here on the left axis the growth rate of the GDP deflator. In other words, we measure the inflation rate. As we have already discovered by the inspection of the different slope of the time series of the GDP deflator, on average inflation rate over the first 40 years had been significantly larger in Germany than the inflation rate after the transition to the European Monetary Union. In fact, most of the years after the transition to the Monetary Union, the inflation rate in Germany had been significantly lower than 2%. So we have not exactly reached the inflation target of the European Central Bank. This is potentially a problem, and we will see how this problem has caused, among other factors, the European debt crisis. That's something we will discuss later. Okay, we've now reached the end of lesson 2. In the next lesson we will see how we can calculate disposable income of households starting with GDP, and we will discuss whether GDP is a good measure for economic welfare or not.